Hi, today we're going to do a walkthrough of the 2012 AP Chem for response number 1. Happy chemistry!
So the question reads, a 1.22 gram sample of pure monoprotic acid, HA, was dissolved in distilled water. The HA solution was then titrated with 0.25 molar NaOH. The pH was measured throughout the titration and the equivalence point was reached when 40 milliliters of the NaOH solution had been added. The data from the titration are recorded in the table below. In the question, it states that the equivalence point was reached when 40 milliliters of the NaOH solution had been added, so I marked the 40 milliliter point. At this point, the pH was 8.62, which is greater than 7, so this means that the solution was weak. If the solution was strong, then the pH would have been 7 because it would have titrated completely away. So for this one, all you have to write is the pH at equivalence point is greater than 7, which indicates that HA is a weak acid.
So HA plus NaOH yields H2O and NaA. But Na is a spectator, so the actual net ionic is HA plus OH minus yields H2O and A minus.
Question C reads, calculate the number of moles of HA that were titrated. For this, we start with the number of liters, not milliliters, at equivalence point. It gives us in milliliters, though. 40.0 milliliters equals 0.04 liters. 1, 2, 3. Next, so we start with that in our stoich. .04 liters, 1 liter, and then into moles of NaOH, 0.250 moles of NaOH. We got this because it was given in our equation above. We're going to take that over and transform the moles of NaOH, so that goes on the bottom, 1 mole of NaOH, into the moles of HA, 1 mole of HA. We found this equation from, this mole ratio from the net ionic that we did in part B. So when you calculate all this out, we get, oh yay, chemistry! 0.04 times 0.250, you get 0.01. So the answer is 0.0100 for sig figs moles of HA.
All know molar mass equals mass per mole. And the mass is given to us as 1.22 grams of HA. And we got, when we calculated the moles of HA, as 0.01 moles. And we find the molar mass to be 122 grams per mole of HA.
We have to find the Ka expression. So for this, we have Ka equals products over the reactants. So H3O plus times A minus over the concentration of HA. Make sure not to use the H2O because it's a liquid. Next, what we're going to do is we're given the Ka value to be 6.3 times 10 to the negative 5. So plug that in. 6.3 times 10 to the negative 5 equals x times x. We can do this because we assume that the x is less than the 0.2 molars that we were given, over 0.2 minus x. Then we know that x equals the concentration of the H3O plus, which equals 3.5 times 10 to the negative 3 molar. pH equals the negative log of the concentration of the H3O plus. So this is the negative log of 3.5 times 10 to the negative 3, which we get to be negative log of 3.5 negative 3. So the pH equals 2.45.
So we take our net ionic equation. And we ignore water because we don't like liquids around here. So to begin with, and we have to do it in moles. So to begin with, we have 0.01 moles of HA, 0.0075 moles of OH minus, and nothing for the A minus because it's a product and the reaction hasn't happened yet. So the changes, we want to get rid of all of our OH because we don't like OH.
It's magic and it disappears.
Woo, magic.
So I hear Robert E. Lee was pretty cool.
So there's going to be no OH because it disappears because it's magic. And there's going to be 0.0025. And there is 0.0075 moles of A minus. Woo, A minus.
I wish that was my grade in chemistry.
Dude, mine's an A, so it's fun.
So now we have to convert it to molarity. So it's 0.0025 divided by 0.08 liters, because that is the liters, which equals 3.13 times 10 to the negative second molar. And for A minus, it's 0.0075 divided by 0.08 liters, and that equals 9.38 times 10 to the negative 2 molar. Assuming that X is much smaller than 9.38 times 10 to the second molar and 3.13 times 10 to the negative second molar, we're going to redo our Ka expression. So now it's going to be X times 9.38 times 10 to the negative 2 molar over 3.13 times 10 to the negative 2 molar. And that's our Ka, so that equals 6.3 times 10 to the negative fifth. And so our H3O plus equals 2.1 times 10 to the negative fifth molar. And there you have it, kids.